Hi everyone, welcome to another screencast video brought to you by Zan Ta from Repo Products. Today's presentation will be on what's new in Autodesk AutoCAD Architecture 2017. Our agenda will focus in on the Repo Products offerings, the new features of the AutoCAD Architecture 2017 software, and then actually getting into the software itself. For those of you who are not aware, Repo Products has been in the business for well over 35 years. We are based in Smyrna, Georgia, and we have a very diversified company, and we offer quite a few services. We are resellers for Xerox, Canon, Osei, Faro, and we are also an Autodesk Gold Partner reseller. So we also sell and support all of the Autodesk products, as well as education, training, implementation, customization. We also have a 3D reality capture division that works with using Faro laser scanning devices. We have a full printing production environment in the offices downstairs that allows us to print small and large wide format prints for all of our clients. We also have a digital plan room to hold all the digital data as well. We have a sister company called the Color Spot that's up in Marietta, and their main focus is on graphics, vehicle graphics, signage, wayfaring, things like that. So if you are local and you want to get a quick tour, come stop by the office and ask anybody to stop what they're doing, and they'll be more than willing to help you with a tour of our facilities. So let's jump into all the new features and enhancements in Autodesk AutoCAD Architecture 2017. We can get into different features such as live sectioning XREF support. In other words, when we're working with AutoCAD Architecture and you have a section that has been generated from an AEC annotation object, when you select the actual section, you can use Edit Live Section and just modify that section at will. Everything will stay linked, everything will update accordingly, and even nested XREFs as well. So the reference in place X-referencing command functions transparently, if you will. When we look at the sections, you actually have an option now to choose Refresh on Open, and that basically means that anytime you open up that particular section or the file that section is in, the section will refresh itself automatically. And this is a nice feature because sometimes you might be working on the plan view and you forget to update the section. When you're working with the section and the actual annotation of that section, you can select that section line and you can actually start to use some of the contextual grips that are available and introduce things such as offsetting it, adding a vertex, adding a parallel jog, or moving it or removing the actual grip. In the new style browser, you have the ability to specify adding directories of not just a drawing, but all the drawings at once. You can include folders and subfolders. It gives you access to all the different styles that are available. And instead of basically using the generic style manager to open and work with a single style file, you can actually bring all of them in at one shot. The style browser obviously has been enhanced and updated for drop-down list and auto-scrolling, just makes it a little easier to function with. And the style browser has also been updated to allow you to input content coming from your A360 cloud account. And they've actually updated the style browser so you can actually close it with the command line. And its placement in the ribbon is a bit more logical. If you're working with the roof command, after you've created the roof, you now have the ability to specify adding vertexes, removing them, offsetting a straight edge, and even taking a straight edge and turning it into an arc. So just a little bit more grip manipulation capability. It's very similar, if you will, to say if you have a hatch and you select the hatch, you'll get the perimeter boundary of the hatch, and it also has grips and markers that allow you to add vertexes, convert lines to arcs, and arcs back to lines. You also have the ability, a nice little new feature, when you're working with the commands like wall, curtain wall, railing, slab, and roof, you can actually tell it to use a subcommand of a shape. For example, a rectangle, a circle, a polygon. So you can very quickly generate the data that you need to generate. And that's it. Let's go ahead and jump into the AutoCAD architecture software and take a look at some of these new features. So here I am in AutoCAD Architecture 2017, and the first feature I'd like to look at is the editing of a section in live mode. What that means is as follows. I have a section here that's been created using the AEC Object Annotation Tools. If I select it, you'll see in the contextual tab of the ribbon, 2D section elevation, you'll see under the Modify panel a command called Edit Live Section. If I select this, it allows me to actually edit into that live section. It creates that link between the section and the plan view. If you have an XREF, for example, that's inside, if you double click it, it automatically enables X-referencing in place, and it's automatic. There's no dialog box that pops up. And you can start to work with objects and design and do things that you need to do. When you're finished, you can end this live sectioning command and save any changes that you have, and it will drill down into all of the XREFs and linking and update everything accordingly. Another new feature is when you take a look at this particular live section and you go to its properties, you'll notice here in the general portion of the properties panel, there is now a refresh on open feature. By default, it's set to no. So if you change it to yes and you save your file, the next time you open up that particular file, it will refresh automatically. Another new feature in Autodesk AutoCAD Architecture 2017 is being able to modify the section defining line. And what that means is as follows. If I select this particular line, I've got my sectioning tool here, and there's some grips now that I can just hover my mouse over, and I can do things like offset, in other words, move its position. I can add a vertex if I need to add a vertex. I can remove the vertex if I need to remove the vertex. I can also click Add Parallel Jog and create a parallel jog if I need to. And so you can kind of manipulate and adjust this. When this is finished, you can go ahead and either generate your own section independent or just select the one that you already have and refresh it, and you'll see the changes automatically. Let's go ahead and take a look at some of the style browser features. If you head over to the home tab of the ribbon under the tools, you'll see style browser. I have mine turned on already. It's docked on the right hand side, so I'll expand it for us and kind of push it out so it's floating. And the way they've enhanced it is as follows. When you select the pull down, your menu will drop down, and you can very quickly, easily see how it's organized a little bit better than before. You can see that you have a drawing source pull down as well. So you can choose between the content library drawings or the project standard drawings or any currently opened drawings. When you're looking at the drawing file drop down, you're going to see your current drawing and any other style-based files you've inserted. Now, I've actually inserted all of mine, and the easiest way that I did that is by clicking Manage Content Browser. You'll notice that this window pops up and it lists all the style DWG files that I've loaded into this particular file. I don't have to go over to the Style Manager window and right-click and say Open File. That's not that old method anymore. So I can click Add Drawings, and it'll take me to the Imperial subfolder by default of the software, and I can, selectively click any one that I want to load, or I can hold one and hold Shift and pick a whole grouping of them and hit Open. Since I've already loaded them, there's no need for me to load them, but I can also click Add Folder. And when I do this, I can specify any other folder or subfolder. I can go to Contents, I can go to Styles, Imperial, and I can pick whatever is in here. Or I can also click the A360 button to get to my online cloud location to pull data from there as well. Another nice feature that's new in AutoCAD Architecture 2017 is the ability for you to grip manipulate a roof, for example, the outlines of it. So I have a standard roof here that I can select, and now you have a lot of little grips that are available. And it's just like I said before with the hatch command. You can put your mouse over and you can offset. You can add a vertex and start to really play with the design of this, if you will. You have the ability to remove that vertex. You have the ability to convert it to an arc and specify the shape of the arc as well. And if it's an arc, you can convert it back to a line. So those are some neat little grip manipulation based tools to help you modify and tweak your roof outline once you've created it. And the last new feature in Autodesk AutoCAD Architecture 2017 is the ability to create shapes when you're working with certain objects. For example, if I start the wall command, if you look down here in the command line, there is a create type feature here that if I click, I can actually choose rectangular, circle, polygon, or P-line. So let's say I pick rectangular. I can just draw a rectangular shape and it automatically allows me to draw that shape using the AEC objects. And that's for walls. Hit escape twice to get out of that. Curtain walls function really the same way. You just head over to pick curtain wall and again click create type and pick what you want, say circle, and then it automatically allows you to draw them. And you can zoom in, we can see. We have railings as well. So if we head over to the Design tab and look for railings, you may see them, you may not. Let's see, there it is, railings. And again, you have create type. I can choose polygon. I can specify how many number of sides. I'll keep 7 is fine. Specify the center of the polygon. I'll just pick somewhere like say here. And inscribe or circumscribe. So it's very similar to the polygon command. And then it'll say specify the radius of the circle. So I'll click like this, and it automatically allows me to create the railing based upon that polygonal shape. And the same feature functions exactly the same way when it comes to working with roofs and roof slabs. And so those are the new features in the AutoCAD Architecture 2017 software. Thank you very much for watching. I hope you got some benefit out of it. And if you need any assistance or have any questions on the new features or any of the Autodesk products, if you need training, you need support, you need customization or implementation, or any other particular service, just get in touch with us and ask for me or ask for your account representative, and we'd be more than willing to help you out. But other than that, thank you very much for watching, and I hope to have another presentation for you guys to see next time.
Hi everyone, welcome to another Autodesk screencast by Zan Ta of Reaper Products. This screencast will showcase how to create a duct system within Revit 2017. I hope you like this video. If you like it and like to see more, please search for Zan Ta or VAR2016. Thanks for watching. Here I am in Autodesk Revit 2017, which contains all 3 flavors of Revit, Architecture, Structure, and Systems. I'm working with a project that is based upon the Systems default template file. And I have some air diffusers and a unit. If we go to the Systems tab of the ribbon, we notice we have a lot of tools here to create manually ducts, duct placeholders, fittings, accessories, converting to flexible duct, so on and so forth. Let's go ahead and select one of our terminals, and we can click Create Duct System. It'll ask us for the type that we're working with and a name, and we'll click OK. We can then click Edit System within the Systems Tool contextual panel, And we can add to this system all the other objects that make up the system. We can also select the main equipment that the terminals are associated to. We'll finish the creation of that system. And then at that point, you can select one of the terminals and click Generate Layout. What this will do is it will automatically go into solution mode and give you different types of solutions to work with. You have network, perimeter, and intersection. Within each solution type, you can click the little arrow here to toggle between what it thinks makes the most sense for you versus what doesn't. If you don't like what you see, you can always switch to, say, perimeter and try the arrows again and see what solutions they give you. If you're still not happy, try the third choice, intersections. And eventually you'll find something you like. And so let's say hypothetically this is what I like. There's a settings button here that if you click, you'll see that the main has a certain height and a duct that's being used. And we'll set that to say 11 feet. And the branch we'll set to 8 feet. Well, no, let's do 10 feet. And then if we want a flexible duct, we can pick a flexible duct to work with. And as you can see right off the bat, a lot of the line work is going to be adjusted for you. Now, if you need to edit the layout, you can click Edit Layout, and you can pick a particular line, and you'll see that's at 11, that's at 11. That one's tied back to the unit, so whatever the height for that unit is, I'm thinking it's 12 feet. This one's set to 10 feet. And so if I need to adjust these to be just as high as those, I can just type in 11 and bring them up. Now that you have the layout idea the way you'd like, go ahead and click Finish Layout, and it will build it for you. If there are issues, it will tell you what those issues are, and then you have to go through the process of cleaning them up. For now, I'm going to leave it the way it is, and we'll worry about it another time. Lastly, if you need to, you can use the Tab key to highlight the entire system and do things like duct pipe sizing and make adjustments for whether the sizing is based upon velocity and or friction or a combination of the two. And you can also restrict the height and restrict the width if you need to as well. And it will try to resize everything for you. And if it works, it works. If it doesn't, you're going to have to adjust it and tweak it to make it the way you want it to look. Now, the choice that we made for this one is not necessarily a good one, the intersection method. So let's try one last approach to creating it again, but a different selection. So I'm going to select this, go to Generate Layout, look at our solutions, and we will pick this one's fine. We'll go to Settings, we'll set this to 11, and we'll set that to 10. Let's see if this will work. Let's go ahead and click Edit Layout, select this, make it 12, take it higher. We'll take the main branch higher. And this one is 12. We'll take this up to 12 just to make it simple. And so let's say hypothetically that's what we want. We'll hit Finish and let it build it. Now if it doesn't build it because there's an error here, you can see what's going on. Let's go ahead and clean that up. So now it's going to put in a little bend. And then lastly, again, you can tab into the system and do things like duct pipe sizing again and let it redesign and readjust the sizing for you. And that's it. That's how you create a duct system. By the way, one last thing, if I select a terminal like this, and I go back to my systems and I click convert to flexible duct, I can pick that terminal and it will convert that portion. So I can use that command all day if I need to pick the ones that I want, and it will convert them to flexible duct. And that's it. Thank you very much for watching. Good morning. My name is Zan Ta, and this is a screencast video on reference planes and reference lines within Revit for an end user who had some basic questions. Here I am in Revit 2016. In the recent files window, I have the ability to create new Revit families or open an existing one. If I click New, it will take me to the Imperial Library of all the Revit family template files to select and work off of to create a new family. I'm going to go ahead and choose generic model just for sake of ease. You'll see in the preview 2 reference planes. If I hit open, it's going to show you the floor plan reference level view. There are always 2 reference planes that they give you as a starting point. And the reason is because when you look at a reference plane and you select it, it will have the name of the reference planes here and here, but it will also specify define origins is checked. The reason they do this is so that when 2 reference planes that have define origins is checked, that intersection represents the insertion point. When you look at it in a plan view, we can easily see the reference planes. These planes are long dashed lines that have 2 open circles that you visibly see when you select the reference plane. The reference planes go out to infinity to my left and to my right, or in this particular instance on the one that I selected, goes to infinity up and to infinity down. The reference plane is coming towards my face, either this one or this one. If I try to zoom out, you're not going to see elevation marker designations. Okay, a lot of people are used to seeing left, right, top, and bottom elevation markers. They're already created. Those elevations are created for you. If I open up Visibility Graphics dialog box and go to Annotations, if I take a look, you will not see the elevation marker annotation category to display that data. So the way to look at it is front, left, right, or back. Front is standing here looking this way, back is here looking this way, and left and right. So if I click the front elevation and go to that, and I do a zoom extents or zoom all, you will see a reference plane vertically, and if you select it, it'll be the center, left, right. So let's go back to reference level, select this says center, left, right. If I go back to the front elevation, there is also a reference level that is set up for you by default, and if you select it, scroll out, and pull it out of your way, like this, it will give you the context to understand this is basically the bottom level that you're working with, and there is a reference plane at the very bottom for the sake of reference and functionality. If you select it, you'll see it does not have a name, which you can give it a name, and whether it is a reference or is not a reference. So it's just there for visual purposes when it says not a reference. However, you can go in here, you can specify strong, weak, or a specific reference plane that's already been created. Okay. What is the difference between strong and weak reference planes? A strong reference plane is when you use the align command, and it will automatically see it, for example, a wall, the left side of the wall, the right side of the wall, the center of the wall. If you choose weak reference plane, then an example of that would be you have multiple lines that represent the multiple layers of a wall, and you can have reference planes within each of those layers, and it will see them only if you hit the tab key. Okay, so here we are in a front elevation, and that's why you only see this one. You don't see the reference plane that's over here. This one is center, front, back. So if I were to go to left or right elevation, I should see, again doing zoom all, a vertical reference plane that says center, front, back. Okay, and so another way to just get visual understanding of what you're working with, if I go over and I create a reference plane, in plan view for the left and the right, and I select it and I give it a name, say my left, and over here, my right. If I go to the front elevation and do zoom all again, you should be able to see the one you made on the left, called my left, and the one on the right, called my right. Coincidentally, if you go in and say, give yourself a dimension to the two reference planes and equalize them so that they stay equal no matter what you do, like so. Again, if I go to the front elevation, I should be able to see that these reference planes have moved. My right and my left reference planes are now equally spaced. So this is the context that you need to visually understand as you're creating and working with creating families. And that's it. That's a quick screencast video on the understanding of what reference planes are. I almost forgot to mention, there's also what's known as a reference line. A reference line is a bit more different than a reference plane. A reference plane is a dashed line that has open circles on either end that go to infinity on either side. A reference line is a solid green line that has a definitive start and a definitive end. The circles are not open, they're solid. And the reason you have a reference line is so that you can host an object on that reference line, and that reference line will control the positioning of the object. For example, if I go in here and I put in an angular dimension, I can parameterize that angular dimension and say call it door swing. Now that I've done this, as I go in here and I change this value for the door swing to say 23, for example, it will rotate this reference line and hold that point position because that's where I drew it initially. It's aligned and locked. If not, you can use the align command to align that point and lock it so you know for sure that it's actually going to be placed on that. And again, you can go in here and you can type whatever angle you need, and it should adjust that object called a reference line. And that's it. Thank you very much. Hi everyone, welcome to my Autodesk screencast. My name is Zan Ta and I work for Repro Products in Smyrna, Georgia. I'm an Autodesk certified instructor and hold many certifications in multiple Autodesk products for the AEC industry. I hope you enjoy my screencast. If you'd like to see more of my screencasts, please search for VAR 2015, that's VAR 2015, or my name. Please don't forget to give me a thumbs up after you watch it. In today's screencast, we'll be taking a look at the callout command and the reference other view command within Revit 2016. Here I am in a Revit project. If I go to the View tab of the ribbon, Create Panel, the callout command exists here. A callout in Revit is nothing more than an enlarge plan. So for example, if I want to do a blow up of this area here, I can click the callout command by choosing either rectangular or sketch based. I'm going to do rectangular first. Start the command, and it's going to ask you to pick two opposing corners. Click, drag, click. You can then move this symbol so that's easy to read, easy to see. The callout is automatically created. The annotation has a blue symbol, which means that if you double click it, it takes you to the view. This view is set at 3/8 of an inch, whereas the parent view that you created the annotation from is at 3/16. What that means is that when you create a callout, it is doubled in scale as opposed to the original that you came off of. If I tile the views and look at them, zoom in here, zoom in here. If I select this symbology, I'm actually selecting the crop region of the view. And I can click and pull and adjust the annotation, which adjusts the crop region. And I can do that over here in the actual view as well. And it will adjust the annotation over here. When you're working with a callout command, that's the first method. The second method is call out where it is sketch based. Everything goes very light and gray, and now it's asking you to draw the magenta lines that represent the outside edges of the custom shape of the call out. For example, say something like this. When you're finished, hit the green check mark. That sketch will be created. This annotation will be created. And you can make the necessary adjustments that you need to make. If I double click it, it will take me to that call out, and it looks like so. When you're working with callouts, you can double click the symbology and it goes into sketch mode, and you can adjust the sketch work if you need to. That applies to non-rectangular and rectangular annotations, callout annotations. So what I mean by this is, if I head over here and scroll down, you see that this is the rectangular one. If I double click it, it goes into sketch mode, and I can change the design of the shape of this if I need to, like that. You'll need to use tools like trim to corner, because you need to have one clean loop, no gaps, no overlaps, no straight lines. And then hit the green check mark, and it will build the updated symbology for you, and it will actually update the view for you as well. So that's the callout command in Revit. The other thing that I wanted to cover was the reference other view. And what we mean by this is, if you're using the section command, the callout command, or elevation command, you don't actually have to have the software build the view for you. You can put a check mark for reference other view, and it will link it to a blank drafting view. So I can click and drag and click, and it puts the symbology in there. But more importantly, it puts in the word sim. And you can see this here. What's happening is that it creates a blank drafting view and linking that blank drafting view to that symbol. You can rename this whatever you want. And in this blank view, you can do whatever you want to do. You can use standard 2D detail line commands and draw your work like so. It stays linked, and so if I double click it, it takes you back to that view. And that is the reference other view. Oh, lastly, if you are needing to create a blank drafting view and not have it linked to any annotation yet, maybe you're working with an intern that needs to create a whole bunch of details or something like that, and we'll figure out where the detail goes later. View tab of the ribbon, create panel, drafting view. Give it a name and a scale, which you can change later. Hit OK. Gives you a blank view called drafting 1. You can rename it, and you can draw again whatever you need to. And that's it. That is the callout command, reference other view command, and drafting view command within Revit 2016. Thanks for watching my screencast, and please don't forget to give me a thumbs up.
So this is a screencast for a request on forums.autodesk.com under Revit Architecture. My name is Zan Ta. This webcast will be used to demonstrate how to create a corrugated panel roof and or wall for the purposes of resolving an issue. Here I am in Revit, and there's a very interesting way of doing this. The first thing you'll want to do is start a new family, and depending on how complex you want this to make, you can create a profile using the profile Revit family template file, and it could be mullion based if you want to as well, and then nest this into a curtain wall panel Revit family template file. For the sake of this video, I'll keep it simple. So I'm going to actually start with the curtain wall panel Revit family template file. It will open up, and here you see in plan, and your objective is, this is the exterior side, this is the interior side, draw a profile that is extruded vertically towards my face, and it will make it look like a corrugated panel. So I'll go here under extrusion, and I'm in sketch mode. I'm just going to roughly put something in. You guys can pull from spec manufacturer information and draw something a lot more exact. This is for the purposes of just getting something down. I also want to use some type of thickness. Say, I don't know, half inch should be okay. Not worried about the depth because it's going to change and adjust anyway. I'll zoom over here and I'll finish the creation of this panel. And then we'll take this and pull this over. Get that in a second. Let's head over to this side. Pull this one back. Over here. And I'm going to pull this one down. Pull this down. Pull that across. And I'll just clean this up. Okay, so this is very rough, but let's just pretend that this is your corrugated panel profile. You head over to the exterior elevation and finish the command, and do ZA to zoom all to extents. You can see it here. You can select it, grab it, pull it up so it aligns the top to this reference plane, and do the same thing for the bottom. This is your panel, if you will. It just looks like this. Again, you guys can be more exact in creating this profile and making it look really, really sharp. But what you want to do next is you'll just go ahead and start a new Revit project or open up the project that you're working with. I'll use Control-Tab to toggle back, and I'll load this panel into this project. Now that it's in there, I could do a couple of things. I can go to the Architectural Wall command, scroll down to Storefront, draw one, go look at it in 3D. See what we've got here. I'm going to select it and go to its type properties. And I'm going to start switching things out. I'm going to switch this with the one that I placed, that I loaded earlier. I just called it Family 2. I didn't actually save it. I'm going to disregard any of the other conditions. I can specify my vertical spacing if I need to. Let's say minimum, I don't know, 4 feet. And then we don't need a horizontal one. And we actually don't even need mullions. So I'm going to take those and set those to none. Once you've done this, you'll delete the grid lines that are not necessary. The horizontal ones and the vertical ones will be left. Now, I'm going to shade it up, and I'm going to tab in and select all my mullions, right-click, select all on host, and hit the delete key to get rid of them. If you look at this carefully, you can see that you've got panels that meet from end to end, and they act like a corrugated panel wall. So that's one approach. Now, if you're working with a roof and you want to make a corrugated roof, if you do the roof command, and we do, say, roof by footprint, or roof by face, they give this other one called sloped glazing. And in order to use this, you actually have a face to select. So I'm going to head over here and just create a mass object real fast. Nothing fancy. And create that, we'll pull it up, and we'll pull this down so that there's a little bit of a slope. And I want to put a roof by face on this sloped wall face right here. So I'm going to go to architecture again, roof by face, pick sloped glazing, select that face, and create roof, and it creates it. Now that it's created, I can go to the properties of it, and we can start making some changes. For example, we're going to go in here and use that panel that we created earlier, and we're going to use, let's say, grid 1, set this to minimum spacing, let's do 4 feet, hit apply, hit OK, and now if you look carefully, you're going to see corrugated roofing. Now again, we can make the adjustments for the spacing. So instead of saying doing 4 feet, let's say we do it at 2 feet. Or no, just go a foot. Let's see what happens if we put it at a foot. So now it looks even more corrugated, and each one is only a foot wide. And same thing here with the wall. This one is set to 4 feet, so let's do 6 inches. And now it's starting to look even or separated. So you can use this kind of trick to build corrugated panels for vertical walls, and then for slanted faces, for, in essence, making a corrugated roof. Here is a quick example of, oh, I don't have that file on me, that's okay. I'll show you guys in another video cast. So this is how you go through the process of creating a custom curtain panel with a profile that looks like corrugated decking or corrugated board, if you want to call it that. Load it into your project and swap out the property information for either a storefront wall or a roof using the roof by face command. And that's it. Thank you very much.